the 7 costly and complicated challenges of big data analytics. Hi, my name is Thomas Hazel, and I'm the founder and CTO here at ChaosSearch. At ChaosSearch, we transform customers' cloud object storage, like Amazon S3, into a massively scalable database, going after use cases such as observability, security, and application insights. Today, I'll be talking about the 5th of the 7 challenges of big data analytics. This episode will cover data platforms. We will outline what they are and why they're important. But the focus will be on the problems one encounters at scale. You should see these episodes as a series where each leads into the next. Think of them as a journey, a data journey, where we'll examine everything from actual sources generating the data to the extraction of value from them. So let's get started. What are data platforms? A data platform, or more topical, cloud data platform, is an integrated set of technologies that collectively meets an organization's end-to-end data needs. In totality, it enables the storage, the delivery, and governance of company data, as well as security layer for users and applications. The heart of a platform is an actual database, where it might be better called a data analytics platform, or in our case, big data analytics platform. And here's where we will focus this episode. A cloud big data analytics platform can take several forms. Often, when it's in the realm of big data scale, a data platform is backed by a data warehouse such as Snowflake or a distributed query engine such as Presto. There are scenarios where NoSQL platforms are also employed, such as Mongo, Cassandra, or Elasticsearch, to name just a few. However, they are commonly used as purpose-built plays for specific use cases, such as front-end web or mobile applications, or back-end financial or operational analytics. Now, NoSQL databases are not typically thought of as a platform's back-end, as they are designed for a specific use case, where SQL databases, by their nature, provide a more generic access to data, and thus fit the bill when it comes to companies building cloud data platforms. However, it is not without saying that aspects and capabilities of NoSQL databases are desirable attributes within a data platform, such as their distributed scale, as well as text, document, and column-oriented functionality. For the driving force of NoSQL innovation was the need for ever-increasing flexibility and scale not seen in data warehouse solutions. This bifurcation ultimately resulted in data sprawl within an IT organization, and thus, by definition, was not achieving the goals of a data platform. There was a time where Apache Hadoop, think HDFS storage and MapReduce queries via schema on read philosophy, had a good run of it. But unless you've been under a rock for the last decade, you know why we're not talking about that today. With that said, Apache Spark, a conceptual derivation of Hadoop, has taken the data lake mantle to address a few Hadoop limitations, where better performance and concurrency were its hallmarks. And today, it is considered a data platform, or better yet, Databricks is, a spin-off of the Spark project, where Databricks now calls themselves a data lakehouse. So far, we've covered what a platform and the types of solutions commonly used to store and access the data. We talked about databases, data warehouses, data lakes with query engines, and data lakehouses. From my perspective, data warehouses come the closest to a pure definition of what a data platform is, where it manages everything from data acquisition, storage, delivery, and governance. I would say data lakehouse come next, NoSQL databases thereafter, and finally, data lakes with query engines last. As one can see, there are a lot of choices, and simple reason is that each one of them does not deliver the whole solution, particularly at scale. The reason warehouses do not fit the bill is the time, cost, and complexity of big data. In other words, the 3 V's of big data: volume, velocity, and variety. And as the other solutions get closer to being a data warehouse, the more they struggle with the same issues. The issues come down to relational model warehouses used to access data through a SQL interface. The relational model is wonderful for accessing information in a generic and powerful way. However, this power comes at a cost in flexibility of changing the schema model and the speed this representation allows for ingestion so that future query performance is optimal. Think of internal over-indexing. These two issues were the catalyst for the NoSQL big data movement, as well as the philosophy of a data lake. As a result, it would seem we are at an impasse. If we want generic power, we lose flexibility and scale. If we want flexibility and scale, we lose generic power. So what is the cause of this dilemma? In simple terms, it's the technology and architecture used to implement them. In other words, each platform uses classic computer science data models and structures for persistence, where each technique has benefits but also drawbacks. In some cases, tons of memory is used to reduce these drawbacks, but this only makes big data scalability extremely cost prohibitive. Data models and structures also drive these type of capabilities a solution has. For instance, column-oriented data models are typically used for relational queries, where inverted indices are more often than not used for text searches. Such a range of functionality forces the siloing of data and their corresponding systems, where data duplication increases the time, cost, and complexity of the overall IT organization. As a result, there has been a hodgepodge of technologies to build out a data platform, where companies now have teams of DevOps, SREs, data engineers, data administrators, and finally solution architects all working together to keep the tsunami of data under control so that SecOps, data analysts, and data scientists can do their job. And unlike other episodes, these challenges seem to only be solved by an army of IT professionals. At Chaos, we saw another way. We saw that there was a need to bring both operational and business intelligence together in one unified cloud data platform. We saw a need for schema on write query performance with schema on read flexibility and scale. We saw a need for search and SQL on all data streams and data sets an organization has, as well as ML analysis. We saw that there was a need to remove the time, cost, and complexity of the data journey to achieve the all-important insights. For anything less is a fail. We started with the core premise that a data lake philosophy of simply streaming data in without predefined schema would make scaling easy and cheap, but could be extremely performant with new innovation. And finally, we started with the belief that schema should be dynamic, instant, and multi-model, and of course, fast. As a result, we sought to crack the proverbial code of information and created computer science that would allow us to transform object storage, such as Amazon S3, into a true analytical database. A database that supports schema on read stream-based ingestion, but looks like a schema on write solution. A solution that supports operational analytics as well as business intelligent workloads and use cases. Now, this does not happen overnight. Databases take minimum 5+ years to build, with a team of very seasoned engineers and architects with 15+ years of experience. We do not take this endeavor lightly, but when it's you and the team's passion to solve such big challenges, one turns a life's journey into a first-of-its-kind product and company. Chaos origins go back to 2012, and now we're a large organization with even more passionate employees delivering on our vision. And finally, if you're interested in learning more about the Chaos Data Platform, as well as our technology and architecture, please go to our website, ChaosSearch.io. And join me on our next episode, The Challenges of Data Analytics, where we will talk about workloads and use cases every IT organization encounters. See you next time.